Thanks for joining me around the virtual telescope. Guess what? Yep, it's back. 3iAtlas. It's back, but not like a lot of people are going to tell you. We just got new images from JUICE. It's the European Space Agency's JUICE, Jupiter by Moons Explorer spacecraft, has captured and transmitted the first science-quality images of 3iAtlas. You can see it here. Only the third interstellar object ever detected passing through our solar system following Oumuamua and Borisov. 3i Borisov. What were the key details from this observation? The image was taken by JANA's science camera on November 6, 2025. The image shows the comet just 7 days after its closest approach to the Sun, perihelion. Distance at the time of the photo, JUICE was about 66 million kilometers, 41 million miles away from the comet. Features: the image reveals a bright glowing coma, a halo of gas, a long sweeping tail, which you can see here in the image. Advancing processing the data shows hints of jets, rays, and filaments spewing from the nucleus, just like we would expect. JANA's provided the visual. 4 other instruments, MAGEUS, SWI, PEP, and UVS, were used to study the comet's chemical composition, including the water content and gas emissions. Bottom line, 3iAtlas is exactly what astronomers say. It was an interstellar comet that visited our solar system. Evidence is in. Here you go. Why the delay? Though the observations were made in November of 2025, the data only reached Earth in late February 2026. This because JUICE was on the opposite side of the Sun from Earth during the encounter. To protect its sensitive equipment from solar radiation, the spacecraft had to use its large high-gain antenna as a heat shield, forcing it to transmit data via a smaller antenna at a very much slower rate. Interstellar origins: unlike most comets from the Oort cloud or Kuiper belt, 3iAtlas formed around another star. Normal behavior. Despite its alien origin, ESA scientists noted that its behavior, spewing gas and dust when heated by the sun, is remarkably consistent with local comets. Compositional mysteries: preliminary data suggests the comet is rich in nickel but low in iron, and has a very high carbon dioxide to water ratio, which provides clues about the environment of the distant star system where it was born. What's next? The instrument teams are currently analyzing over 120 more images and various spectrometric data. They're scheduled to meet in late March 2026 to discuss their full findings and what this visitor tells us about the chemistry of other solar systems. So purely, this is a visitor, an interstellar comet from another star system that got expelled, has been traveling through space, visited our solar system, behaved very much like the comets that we have here, except for the composition. The composition reflects more of what was going on in the star system it developed in than our star system. So great news. Just thought you'd find this fun. Thanks for joining me. We'll catch you next time.